this is our exponential function. We've graphed it. So start by creating a table of values. We did that check. We graphed it. Now we can figure out the domain. So question of the class, what is the domain? How do I figure out the domain? Well, we always start off by writing the domain like this. X belongs to all the real numbers such that, what are the possible values of x? Well, does this function go all the way to the left? Is this function going all the way to the left? And the answer is yes, because of this arrow here, we know that it's going to go to the left and up. So it's definitely going to the left. And what about to the right? Is this function going to the right? And the answer is yes, this function is going to the right because of this arrow here. So it's going to continue going all the way to the right. Right? So that's it. We actually don't need that sign because, oops, there's too much. Oh, okay, I don't know what I did there, but it doesn't matter. It's just going to be XER, and that's the answer for the domain. Because x is just every single possible value. There's no restriction on x, and it continues left and right. What about the range? Does this function go all the way up? And the answer is yes. Because of this arrow here, function does go all the way up. Does this function go all the way down? And the answer is no. There is no function down here. It never, goes down there. So that means there has to be a restriction of some sort. Or rather a condition, not a restriction. Well, it is a restriction. All right, x belongs to all the real numbers such that, nope, I made a mistake, because like a lot of you too on the test, I don't know why. For some reason, your range, you wrote x. I don't know why, but range is always in y. So YER, such that y is greater than and equal to, or just greater than 0. And in this case, it's just greater than 0, because y will never actually be 0. And we went over that when we first introduced this, or you can watch the videos and lessons, and they will go over that. What is my x-intercept? My x-intercept is none. There is no x-intercept. Why? Because it doesn't actually touch the x-axis. What is my y-intercept? My y-intercept is this value here. And that is when my x value is 0. So when x is equal to 0, y is equal to what? It's right over here. We actually have the table of values to help us here. We did the math. So when x is 0, y is 4. So my y-intercept is 4. Intervals of increase and decrease. There is a nice video that goes over this. But to quickly just tell you, this function is going, remember, you always read from left to right. So you start from the left, up here, and we're going down, 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 down. So that is considered an interval of decrease. And what is the interval of decrease? It's all x values. So from XER you can write if you want, or from negative infinity to positive infinity is the intervals of decrease. There is no intervals of increase. There is no intervals of increase for this specific function. It's XER, meaning it's all the x values, all the real numbers, or if you want to write it like this, negative infinity to positive infinity, that's fine too. Asymptote, there is no, not applicable, there is no asymptote, there is no vertical line that splits the graph into two. There is no asymptote, so any. And that's the answer. Let's take a look at the answer. Here we go. Yeah, looks like my graph. XER, y greater than 0, no x-intercept, y-intercept of 4, x increases as y decreases, or the function is decreasing, or the domain. So yeah, so this is how you're supposed to actually write the intervals using words. So the function is always decreasing, is the answer. Oh, wait. Oh, I'm so sorry. There is an asymptote. I was too quick. So there's no vertical asymptote, but there is a horizontal asymptote. Forgot about that actually, which so sad for this unit. Oh my gosh, I'm just making a mistake. Sorry about that, kids. So there is an asymptote. There's no vertical asymptote, but there's a horizontal asymptote. So just be careful with that, because the function never goes below this part, and never actually touches and reaches that point. And the function, the equation of the asymptote is y equals 0. because it's a horizontal asymptote. Had it been a vertical asymptote, it would have been x equals something. But yeah. And this is why you always check the answers, in case you miss something, you're going too fast. All right, let's do one more. Second example for a graph is this one here. So same thing, values. I'm just going to do, I like my symmetry, so I'm just going to do this. So that's a -2, -1, 0, 1, 2. For my x values, nice whole numbers, easy to calculate. So now if my y is equal to -3 to the power of -2. So remember that minus sign is there. Don't forget that minus sign. And we're substituting a -2. This actually changes my exponent to +2. And since this negative sign is outside the bracket, and you'll be like, oh, what bracket? Well, exactly. Because there's no bracket, it's outside the bracket. Otherwise, you have to show it being inside the bracket. So what does it mean when the negative sign is outside the bracket? That means that when we're doing the order of operations, we always do exponents first. So this negative sign doesn't get squared. That 2 is not applying to that negative sign. It only applies to the 3. Because it only applies to the 3, the answer is now 3 squared is 9. And then you multiply the negative sign. Remember, the negative sign is just a multiplication of -1. That's what a negative sign really is. If I write -4, that's basically -1 times +4. And we don't obviously write like this because it's just extra space for no reason, taking time and effort. But in this case, just so you know how the math works, I'm writing it out. And then the final answer is -9. So when x is -2, y is -9. Let's do the next one, -1. So y is equal to -3, -1, which is -3 to the power of +1, which is -3. So the answer is -3. And then y is equal to -3 to the power of -0. Now -0, anything times 0 is just 0. So that's just the same thing as -3 to the power of 0. And that's just, what's 3 to the power of 0? 3 to the power of 0 is 1. But remember, there's this negative sign here. So it's actually negative times 1, or -1 times 1. It's -1. So just be careful with that negative sign. Because this negative sign is outside the brackets, every single answer will always be negative because the exponent can never change a positive negative sign. And that's key. That's important. A lot of students don't understand this. They think the negative sign from the exponent somehow changes the positive negative sign of the number. And that is false. The exponent can never ever influence a positive or negative sign. It doesn't have that power. So if the answer is always going to be negative, it's always going to be negative. If the answer is positive, it's always going to be positive. If the only thing you're changing is the exponent. Obviously, if you change other things, that's different. But if you're just changing the exponent, like in this example, this answers will always be negative. And at this point, I'm just going to use my, thing of like growth factor. I'm like, okay, well, I know the growth factor is now what? Well, y is equal to a times b to the power of x, right? I can rearrange this to write it like this. So my a value, if you haven't figured out, is the negative sign. But it's a number, so it's -1. My a value is -1. My b value, is my b value 3? Yes or no? What do you guys think? I'm going to do a poll on this. And if you look at the equation here, y equals a times b to the power of x, the x, the heck is that? I don't know what that is. It's probably my kid. The x is a positive exponent. And here, the x is a negative exponent. Before you can even write it like this, you need to change that negative exponent into a positive one. How do we do that? If you remember correctly from exponent laws, which we went over on Friday, you need to flip the fraction. what